Today we're looking at section 12.4, which is infinite geometric sum. You're going to need your cheat sheet so you can get this fifth formula for chapter 12 written on your cheat sheet. If you want to sum an infinite amount of values, there's two possible scenarios that you need to look at when you're looking at the equation. If the common ratio value, absolute value of the common ratio value is greater than or equal to 1, there is no sum. Your numbers just keep getting larger and larger and larger, in which case the sum keeps getting larger and larger, and there isn't an exact value for that. Case number 2, if your absolute value of your common ratio is less than 1, then yes, you can find the sum, and the formula is this. The sum to infinity is equal to the first term over 1 minus common ratio. That's it. First term over 1 minus common ratio. Make sure you get this in your notes and make sure you put this formula on your cheat sheet. This is equation number 5 from this chapter. All right, let's look at a couple examples here, and you'll need your calculator so you can come up with some answers, and you'll see where this sum to infinity is coming from. Here we have a sequence 1/2 plus 1/4 plus 1/8 plus 1/16, and so on. We want to find out a few sums for this. The sum of the first 5, the sum of the first 15, the sum of the first 25, and by then you'll be able to see a pattern. First thing I need to be able to do is write the explicit formula, in which case I need to know the first term, which is 1/2, and I need to know the common ratio. Common ratio, 1/4 divided by 1/2. Now remember, you could do this without a calculator if you have to. 1/4 divided by 1/2. Same thing as 1/4 times the reciprocal, times 2 over 1. That gives me 2/4 is 1/2. So this common ratio is 1/2. Do it again. 1/8 divided by 1/4. Same thing as 1/8 times 4 over 1, which again is 4/8, which is 1/2. So my common ratio is 1/2. So my explicit equation is 1/2 times 1/2 raised to the n minus 1. So what if I want to find the sum of the first 5 values? Well, according to our geometric sum formula, first term, 1 minus common ratio raised to the 5th over 1 minus common ratio. Now, when you plug this in your calculator, I would suggest that you do this from the inside out and do it one piece at a time. Then you'll be less apt to make a mistake if you try to type it in all in one command from left to right. All right, so I want you to type in, and for 1/2, use a decimal 0.5. 1 minus 0.5 raised to the 5th equals, divided by 0.5 equals, times by 0.5. Do you come up with 0.96875? Hopefully so. The sum of the first 15 terms, let's do it again. 1/2 times by 1 minus 1/2 raised to the 15th over 1 minus 1/2. Plug that one into your calculator. Again, go from the top down or inside out. 1 minus 0.5 to the 15th equals, divided by 0.5 equals, times by 0.5. 0.9996. Let's try it one more time. See what you come up with when you do the sum to 25. 1/2, 1 minus 1/2 to the 25th over 1 minus 1/2 equals. You should see that it's getting closer, 0.99999, depending on how far your calculator goes out. So if you see that you're looking at your sums are slowly getting closer and closer and closer to 1. So now if we try our actual infinite formula, and the infinite formula will work here because the common ratio is a number that's less than 1. So according to that, I need to do the first term, which is 1/2, over 1 minus my common ratio, which is 1/2. 1/2 divided by 1/2 is 1. So the sum to infinity is 1. Next example, 2 plus 2/3 plus 2/9 plus 2/27. My explicit equation, a sub n equals first term times common ratio What is 2/3 divided by 2? 2/3 divided by 2, same thing as 2/3 times the reciprocal of 2, which is 1/3. 2/9 divided by 2/3. 2/9 times by 3/2. The 2's cancel. I'm left with 3/9, which is 1/3. My common ratio is 1/3. Explicit formula, 2 times 1/3 raised to the n minus 1. If I want to find the sum to infinity, it works because my common ratio is 1/3. So it is 2 over 1 minus 1/3. You don't need a calculator for these sometimes, you know. Some of these infinite ones are very easy. 2 divided by 2/3, same thing as 2 times 3/2. Infinite sum is 3. Next one. 1, -3, 9, -27. -3 divided by 1 is -3. 9 divided by -3, -3. My explicit formula is first term times common ratio raised to the n minus 1. Common ratio, the absolute value of that number is 3. That is not less than 1. There is no infinite sum. On page 821, here are 3 questions, just so you can see what the infinite sum questions could look like if you have to see them in sigma notation, summation notation. So on the bottom of the page, number 2 says, find the infinite sum. Remember your symbol, sigma, is find the sum of the first to the infinite, according to this rule, -1/2 raised to the n minus 1. Do you notice you do not have a first term in here? There really is one. It is 1. So sneak a 1 in there if you need to. That is your first term. Since this value, absolute value of that, is less than 1, then there is a sum that I can find. First term over 1 minus my common ratio of -1/2. That'll change to a plus plus. 1 divided by 1 plus 1/2 is 1/2, which is 3/2. 1 divided by 3/2, same as 1 times 2/3. My infinite sum is 2/3. Number 3, find the infinite sum of this equation. 3 times 5/4 to the n minus 1. My common ratio is 5/4. 5/4 is greater than 1. No sum. Number 4 is pretty much like what we did back here with these last 2. So we'll skip number 4 for right now. If you want to try this one on your own, you should come up with the sum of 4. I'll let you try that one by yourself. This next example that's in your section, how can you write a repeated decimal as a fraction? 0.242424. Well, if you write this out as a sum of values, you need to look to see where the values repeat. So it's 24, 24, 24, and so on. So what we do here is write the first set of numbers before they start to repeat. So in this case, it's going to be 0.24. Plus, well, it's going to be that same start number, 0.24, but then I need to know what to multiply it by. If I'm using 2 decimal spots, 2 decimal spots represents 0.01. So I need to multiply in my sum 0.24 plus 0.24 times 0.01. And then it would be 0.24 times 0.01 squared. And then 0.24 times 0.01 raised to the third, and so on. So this 0.242424 has an explicit formula of first term, 0.24, times common ratio, 0.01, raised to the n minus 1. Can I find the sum for that? And this should actually be infinite right here, infinite sum. So the infinite sum would be first term, 0.24, over 1 minus common ratio, 0.01. 0.24 over 1 minus 0.01 is 0.99. And now it's really easy. Move your decimal point 2 spots, and you come up with 24/29. That is what's called writing a repeated decimal as a fraction. So in a sense, you're finding the infinite sum. 24 over 29. This next one, 0.555, let's see if we can follow the pattern. I only have one value that repeats, it's the 5. So my equation should look like 0.5 times 0.1, there's only one spot, so I only need to use 0.1, raised to the n minus 1. So now if I write my infinite sum, it would be first term over 1 minus 0.1, 0.5 over 0.9, move your decimal point one spot on each part. My fraction is 5/9. 72. 0.72 times 0.01 raised to the n minus 1. Your infinite sum, first term over 1 minus 0.01. Are you noticing the pattern yet? 0.72 over 0.99, 72 over 99. Some of these might reduce actually. 72 over 99 would reduce 8/11. This one back here, was it 24 over 9? This is a 99, sorry on that one. 24 over 99 would reduce 8/33. You could reduce that. Okay, so if you could do this one, 0.1313, and jump right to the fraction form, like that, could you do it? 0.13 over, guess what the bottom is? 0.99, 13/99. There you go, 13/99. You'll have a couple of those to try in your homework. Okay, now we have two word problems that we need to talk about, where you can use an infinite sum. This is the pendulum question. It's on page 822 in your book. So you pull a pendulum back 18 inches, and then you let it start to swing. When the pendulum swings, it swings back 80% each time. So 80% of 18, and then 80% of that particular number, and so on, back and forth and back and forth. What we want to try to do is write the explicit formula first, and then based on the explicit formula, can we find the sum? Well, explicit formula, remember, has to be your first term. First term is 18, and then common ratio. What does it swing back by each time? 0.8, raised to the n minus 1. 80% would be 0.8. Does this qualify as an infinite sum? Sure it does, because 0.8 is less than 1. So if I want to find the sum to infinity, let's change the n to an infinity, I need first term over 1 minus 0.8. 18 divided by 0.2, and then you can punch that in. Should be 90. And I think our label is inches. 90 inches. The last one is the ball dropping question, and you'll have one like this to do in your assignment. So this one is really important to watch. You're going to drop a ball from 60 inches on the first drop. So the ball starts way up here, and it drops a total of 60 inches in the first drop. Each bounce takes it to 2/3 of the previous height. So it's going to go up 2/3 of 60. So the first thing we need to figure out is what's 2/3 of 60? 40. Well, once it gets to a height of 40, gravity is going to take it right back down again, 40. And then it bounces 2/3 of that. So 2/3 of 40, 26.6. And then gravity is going to pull it back down, 26.6, and so on. So it keeps doing a matching up and a down, and then up and a down, and then an up and a down, and so on. And it keeps getting smaller and smaller and smaller. I want to find the sum total of all of the bounces, all of the total distance. The total of all vertical, which would be all up and down. So when you look at a picture like this, and it's really important to look at a visual, when you look at a picture like this, do you agree that you have a matching up and a down, up and a down, up and a down everywhere, except for this first initial drop of 60? So you've got one matching up and a down of 80. You've got another matching up and a down, 26.6 plus another 26.6. You've got another set of matching up and downs. Every single one of these is a matching set of an up and a down. The only thing that's out here by itself is the 60. So to reflect that, we're going to do the sum of 60 plus all of the up and downs. Sum to infinity of all up and down. So can I write an explicit formula for the matching sets? Well, each time it goes 2/3, but I need to know a start number. So remember in your explicit formula, a sub n, I need to know a first term and then my common ratio. My first term is the entire round trip of the up and a down. Up and a down 40/40 is 80. So my initial term for the up and downs is 80, and then my common ratio is 2/3, and minus 1. So what I'm adding together then will be 60, the initial drop, plus the infinite sum of 80, 2/3, and minus 1. This infinite sum is doable because the 2/3 value is less than 1. So I need to do first term of 80 over 1 minus 2/3, 80 over 1/3, same thing as 80 times 3 over 1, which is 240. Then I get to add in my first drop. So I have a grand total of 60 plus 240, 300 inches. Total vertical of the ball, up and down, up and down, up and down. Your question in your book will be very, very similar to this. So please remember that when you do the first drop, this first drop is a guy that's sitting out there by itself, does not get included in the rest of the infinite sum. So this guy's got to be sitting out by itself. Then do your infinite sum of all of the combined round trips, up and down, up and down. And the first round trip represents your A1 term. In this case, it was a total of 80. So please keep that in mind when you look at your question from your homework. All right, that's it. So double check your cheat sheet. Make sure you now have all 5 formulas for Chapter 12 on your cheat sheet. Okay, you're ready to go ahead with your next homework.